Alright, morning guys. So, Algebra 2. Yesterday we were talking about what was called rational functions. Okay, and the root, rational here, the root of that was ratio, and by ratio we mean dividing, right, like this. And we were talking about how to kind of simplify these things. So you have a polynomial in the top, the numerator, and a polynomial in the bottom. We did example number 9, but it kind of didn't work out. Some of the numbers weren't good, so nothing canceled out, and sometimes that happens. But when we're going ahead and doing this, when we get down to our simplified answer, we need to state our restrictions. So what can x not be? And so we would get down to our answer, and at the end we'd put a comma and say like x can't be, in this case, like, I don't know, would it be 4 or 2 or anything like that? Okay, so these are called the restrictions, and they have to do with the domain. Now what we're going to be doing today is we're just going to be going ahead and finishing up the rest of the notes. So if you want, strap on your seatbelt and we will get going. Little movie magic. So in the top for number 10, we actually have what's called a difference of 2 cubes, because if you remember, 8 is a special number. 8 is 2 cubed. Now normally we don't have anything cubed up here, and so this one is actually going to be really kind of hard. We're going to come back and do this one at the very end, so we're going to skip number 10. Okay, now just to kind of say where we're going, we would have to x factor this, and we're actually going to have to use synthetic or long division to factor this out a little bit. Alright, but for right now let's go ahead and skip it and move down to question 11, or I guess it would be across for you guys. So you'll notice for question 11 we have 10x plus 8 on top. We also have 10x plus 8 on the bottom. So anytime we have something that's on top that is also on the bottom, okay, for example, like if we had 7 over 7, you can simplify that and say 7 over 7 is 1. If you add 1.3 over 1.3, that is just 1. It works the same thing for polynomials. If we have 10x plus 8 over 10x plus 8, we know that that has to equal 1. Now the only thing that we have to do with this is state the restriction. So our answer is 1, okay? And I can show you guys a graph of this at some point when I get back. But there are certain x values that will make the denominator 0. And remember, you cannot make that 0, okay? So can't be 0. You will get sucked into the vortex of death and you'll die. So we have to say, what values for x would make this 0? So we have 10x plus 8. We want to know what numbers make it so it's not equal to 0. Okay, what numbers do we have to exclude? So we're just going to go ahead and solve that denominator for x. So we're going to subtract 8. Subtract 8. This is kind of the long way of doing it because we didn't have to factor anything out. 10x equals negative 8. Divide by 10. Divide by 10. So we know x has to equal negative 8 over 10, which if we simplify that is negative 4/5. So this is our restriction. Overall, our answer is 1. Okay, but we know that x cannot be negative 4/5 because that makes the denominator 0. Okay, so this is kind of what I'm looking for. Beautiful straight line. And again, if I'm going too fast, feel free to pause things. Not opposed to that at all. Moving on to number 12. Okay, we notice the top is 10x plus 8, and the bottom is just 10x. Okay, so we can't x factor either of those. They aren't trinomials. Okay, they aren't quadratics. So I'm just kind of looking and seeing, what can I divide the top by? Well, 10 and 8 are both even numbers. Okay, so I'm going to divide the top by 2. Take that whole thing, divide 2 out. Okay, I also see that 10x, okay, maybe I can divide a 2 out. I'm just trying to divide things out that I might be able to get rid of later. So divide by 2. So in the place here, instead of 10x, 10x divided by 2 is 5x. Then we have our plus, and then 8 divided by 2 is 4. So we have 5x plus 4, and we divided a 2 out, okay? So that's why my 2's out in front. If I were to distribute that back in, let's see, we would get back to the 10x plus 8, okay? So let me undo that. On the bottom, we divided that by 2, So we have a 2, and then we just have 5x left over. Okay, so now you'll notice that we have a 2 on top, we also have a 2 on the bottom, so anytime we have something on the numerator and something in the denominator that is the same, we just go ahead and cross them off. Alright, we are left with 5x plus 4, a little laggy, over 5x. Now, be careful, because I know a lot of people are like, well, we have 5x in the top, 5x in the bottom. Well, we can't really do anything with that because we have this 4 kind of ruining the party. Okay, so if we wanted, this is just another way to do it. Okay, we could take the 5x plus 4, and what we would have to do is we'd have to divide both of those terms by 5x. So by 5x. Now, this isn't any better than right here. Okay, it's just another way of looking at it. Now, if we take 5x divided by 5x, that's just 1. And then you have this kind of goofy leftover fraction part at the end, 4 over 5x. Okay, so this is just another form. We could go ahead and state our restrictions after that. I personally like this format a little bit better, so that's probably what I'm going to do. I'll show you both though. So the thing that would make the bottom 0, well, of course, 5 times 0 is 0, so x cannot be 0. Okay, if we're going back here, okay, we just have the 5x plus 4. Oofda. That is a 4. Let me erase that. Wowie, look at that. So 5x plus 4 over 5x. Perfectly fine with this. We put our comma, state our restrictions. X can't be 0. Alright, let's see if I can make a nice square box. Woo! Perfect. Alright, so this is kind of what I'm looking for. Our simplified answer, our simplified rational function, along with our restrictions, what x cannot be, because you don't want to divide by 0. Alright, let's go to the next one. For 13, on top we have something squared, so I'm thinking we probably should use the x factor. Okay, and then we just have a thing on the bottom, x plus 4. Okay. And so when we are looking at the top, we could just do the x factor. Okay, we have the middle term missing. But I think if you notice, and if you remember way back to quadratics, we called this the difference of two squares. Okay, so I will write out what I mean when I say that. This is the difference of two squares because it is x squared minus 16, which is 4 squared. So we have something squared minus another something squared. And anytime we have this format, it is special, 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 special. And we don't even have to do the x factor. All we have to do is make that x minus 4 and then x plus 4. Since it was 4 squared here at the end. Alright, if you were to FOIL this out, so take firsts, outers, inners, and lasts, double distribute here, you would get back to that original x squared minus 16 because the middle things cancel out, the middle terms. So let's go ahead, and that was kind of our factoring of the top. So we have x minus 4, x plus 4, and that, let's see, shift. I said shift, which is what makes those straight lines, not the S word. X plus 4. And now we notice we have some x plus 4s in the top and the bottom. So we go ahead and cancel them out. We're left with just the x minus 4 hanging out on top, which we can just put over 1, which is just x minus 4. And we state our restrictions. Hey, Mr. Johnson, x cannot be. What would make that 0? Well, just negative 4. Okay, so let's make our nice box around that. Perfect, that's what I'm looking for. So in the end we get x minus 4, but x cannot be negative 4. And if you guys have questions, okay, I can always go over it when I get back, but this is kind of just to get you through the notes, make sure that you guys are doing this kind of properly. And if you wanted, you could always pause the movie and try some on your own and then double check your answers. Alright, for 14, we have x minus 3 on top, and then we have a quadratic on the bottom. So x squared minus 8x plus 15. So anytime you see that, you got to be thinking, ooh, let's try to x factor that. Okay, it's the easiest way to do it. So the first 1 times 15, that goes on top. So 1 times 15 is 15. On the bottom, we put the middle number, so negative 8. Negative 8. So we think to ourselves, what multiplies to 15 but adds to negative 8? Well, I'm thinking 5 and 3 are pretty good candidates, but 5 and 3 don't add to negative 8. So we have to think, what if they're both positive? Or sorry, excuse me, negative. So negative 5 times negative 3 is 15. Negative 5 plus negative 3 is negative 8. We always divide by the a value, divide by 1, divide by 1. So when we're going to write our factored form, okay, and remember, this is on the bottom. Okay, so it needs to stay on the bottom. When we take that fraction and write it in factored form, this would be x minus 5, okay, 1x minus 5, bottom, top, and the other factor would be 1x minus 3, which is just x minus 3. So that's the bottom. We go ahead and rewrite the top. Top was already kind of simplified for us, x minus 3. We notice we have a couple x minus 3 bits, and we cancel them out, cancel out those factors, and we're just left with x minus 5 on the bottom. Now, do we need something up top? Do we need something up here? You betcha we do. Okay, anytime we cancel things out, really this is 1 over 1. Okay, so really what's on top is a 1. So 1 over x minus 5. Now, we get done with this, we state our restrictions. X, first off, can't be 5. That would make our answer here 0 in the bottom. So x cannot be 5, and then we have to look back to our original 2. Anything that canceled out can't have the numerator, or sorry, the denominator be 0, so 3 minus 3 would make that 0, so x can't be 3 either. Go ahead and box our answer, and call it a night. Call it a night. So top, looks like we're going to try to x factor this. So let me go ahead, let's make our x. We take our first, which is 1, times our last, negative 6. So 1 times negative 6 is negative 6. And in the bottom, we have negative 1, the middle term here. So what multiplies to negative 6 but adds to negative 1? I'm thinking 3 and 2 somehow, but we need to make one of those negative to multiply to a negative. So it has to be negative 3. That's the only way we add to get negative 1. We divide by 1, divide by the a value on the top. From this fraction, we get x minus 3, and from the other one, we get x plus 2. You guys are going to just be wizards at x factoring after this whole target. On the bottom, you'll notice we already have this term, x minus 3, so we're kind of saying, ooh, cancel things out here. For the other part of it, okay, the x squared plus 7x plus 10, we're going to have to x factor again. Alright, so 1 times 10 is 10. And then we put that 7 in the bottom. What multiplies to 10 but adds to 7? Well, you guessed it, 5 and 2. Oh boy! So, divide by our a value, which is 1. We get x plus 5. X plus 2. That's in the bottom. And we can cancel out actually a bunch of stuff. So the x minus 3s and the x plus 2s, remember anytime things cancel out all the way on the numerator or all the way on the denominator, there are 1s in its place. So we have a 1 up top, and then we have an x plus 5. I might have gotten a little overzealous with my fraction bar here. Alright, after we do that, we just state our restrictions. So x can't be, first off, 3, okay, that would make that term 0. It can't be negative 5, and it cannot be negative 2. Any of those numbers would make this whole bottom 0, the whole denominator, and you cannot divide by 0. Okay. Okay, moving down to 16. Okay, the top. This only has 2 terms, and actually, if you're looking kind of close, 9 is a special number, 25 is a special number, and so you're subtracting them. You should be getting kind of the hint here that this is the difference of 2 squares. Okay, so let's write that in. Okay, it's going to be kind of important for you guys to be able to recognize that, so some practice is definitely going to help. Difference of 2 squares. Alright, so how would we make 9x squared? Well, that's just 3x squared, okay? Because 3 squared is 9, x squared gets you the x squared part. And then we're subtracting what? Oh, just 5 squared. So 3x squared minus 5 squared. So when we go ahead and rewrite that, it's going to be 3x minus 5, 3x plus 5. Okay, so let's actually do that right now. Make my fraction bar, 3x minus 5, and 3x plus 5. Now, if you wanted, you could go ahead and x factor that, but it's just easier to kind of recognize that it's a special case and avoid all of that work in the first place. Now, for the bottom, okay, we are going to need to go ahead and x factor this. One thing you always need to keep in mind, though, too, is if anything divides out. So if 6, 11, and 35 have a common multiple, they're all factors or multiples of something, you need to divide that out first. We're going to see that in a couple questions here. So if you're taking 6 times negative 35, 210. So this should be negative 210, and we need to add to 11. Okay? So, 210. One way that we can get there is by multiplying by 10. So it'd be 21 times 10. And so that's kind of the easiest one that I think of first off, because there's a 0 at the end. So 10 is kind of what I go to. So 21 and 10, well, it just so happens that the difference between those, 21 and 10, the difference between those is 11. So I just need to make one of them a negative. Okay? So in order to get a positive 11, it's the 10, the smaller of the two numbers, that needs to be negative. 21 times negative 10, negative 210. 21 plus a negative 10 is 11. Okay, and it sometimes just takes a little bit of guesswork. Now I need to divide by 6, that number out in front. So divide by 6, divide by 6. Okay, this 21 over 6, none of those, actually they do. We can divide them by 3's, excuse me. So we're going to divide that by 3. We get 7 over 2. Okay, and here we are going to divide by 2's. So we're going to get negative 5 over 3. So writing out our factors here, we have 2x, because the 2 goes with the x, and plus 7. For the other one, we have 3x minus 5. Okay, and we're looking, is there anything in the top that's also in the bottom? Well, we have a 3x minus 5 and a 3x minus 5. So we go ahead and cross those off. And what are we left with? 3x plus 5 in the top over 2x plus 7. After we do that, we state our restrictions. Okay, so first off, x couldn't be whatever would make this 0. Now, you could just go ahead and solve. You could say 2x plus 7, when is that equal to 0? Because we don't want it to be equal to 0, but that's kind of a lot of work. Okay, we did this x factor thing over here for the bottom. Let's use some of these numbers to figure out what the zeros have to be. So the 0 for this guy would be 7 over 2, but remember, it's the opposite of that number. So x can't be negative 7 over 2 from this guy, okay, from this term. If you'd solve that, that's exactly what you would get. And for the other one, it would be positive 5 over 3. So x can't be either of those numbers, okay? 5 over 3. I hope that doesn't get cut off. So when we've simplified, we got 3x plus 5 over 2x plus 7, and then we have these restrictions, which it's easy to come from and get by doing our x factor and just taking the opposite of those simplified fractions at the end. Okay? 17. Okay, so this is one of those questions where you have to look and see, do all the terms have something in common? So in this case, 4, 16, and 180. Alright, in fact, we can divide all of those by 2, okay, and then you'll see you can divide it also again by 2. So we can divide this whole thing by 4. 4, 16, and 180 are all multiples of 4, and that's the biggest thing that goes into them. Okay, you can't go bigger than the smallest number. So on the top, we're dividing out of 4, So we get x squared minus 4x, 16 divided by 4, and then 180 divided by 4, 45. All right, so minus 45. Okay, so we're going to be dealing with that simplified version of that quadratic rather than this big nasty one with 4 times negative 180, because that is just a nightmare. So that's the top. Let's see if we can do anything with the bottom. 4, a 28, and a 32. Well, it just so happens that those are also multiples of 4, so let's go ahead and divide those by 4. So we're going to put a 4 out in front. 4 divided by 4 is 1, so x squared. 28 divided by 4 gets you, let's see, 7, so minus 7x. And then 32 divided by 4 gets us 8, so minus 8. Alright, so now we have two much nicer quadratics to deal with the x factor. So I'm going to go ahead and do the top kind of over there. So I'll do that over here. And the bottom kind of below it. Alright, so in our x factor, we have 1 times negative 45, which is negative 45. Okay, in the bottom of that x, we put a negative 4. So what multiplies to negative 45 but adds to negative 4? Well, 45, I'm thinking 9 and 5. That's an easy way to get there. And we can somehow maneuver those to make one of them negative, so that they add to negative 4. So the 9 is negative. We divide that guy by 1, because there's a 1 in front of the x squared. And we can go ahead and rewrite that top. Okay, let me do my x factor for the bottom first. Okay, so let's set up the x. 1 times negative 8, negative 8. In the bottom, negative 7. So I'm thinking, 8 and 1 probably. But which one has to be negative? The 8. That's the only way they're going to add to negative 7. Divide by 1, again, that a value. So we have our fractions here, and we can write our factors. So let's make our line. Can't forget this 4 hanging out. So 4 times, from this fraction up top, x minus 9. Okay, from the other one, x plus 5. Okay, so that's the top. If we were to distribute all of these things, we would get back to our original problem. Yippee. Now for the bottom, can't forget that 4. So 4 times x minus 8. And then x plus 1. If we're looking at this, these factors, actually, none of them cancel out. Okay, there's nothing on the top that's also on the bottom. The only thing that we have are these silly little 4s that we dealt with at the very beginning. So the answer, okay, once we kind of see that, is just going to be that x minus 9, x plus 5, that's in our numerator, x minus 8, and x plus 1 in our denominator, and we just need to say, hey, Mr. Johnson, we cannot use 8 from that first factor, and we can't use negative 1 from that second factor. So this would be our answer. Not very pretty, probably not getting asked out to the math prom, but that's okay. It's sophisticated. Alright, so that kind of finishes out our notes, except for that one way at the beginning. Okay. Before we do that, I would like for you guys to go ahead and do the little writing prompt at the bottom. What do you do? Okay, what's kind of the big idea for the notes? Alright, so if you want, you can go ahead and pause the video, do that. Alright, coming back up here to the top for 10. Okay, the difference of 2 cubes, that's one of the things we did when we were doing synthetic division. So what we're going to have to do is we have to think, what number cubed minus 8 would make that 0? So we know 2 cubed works. So since 2 works, that means we know x minus 2 is a factor of this thing. Okay, it's a factor. So what we have to do is we have to do a little synthetic division. I know this is going way back. So 2 goes in our box, and then we have 1 for the x cubed, we have 0 for the x squared, we have 0 for the x, and we have a negative 8. Okay? going way back. Right? So we have all these numbers. It goes all the way down to just our number from x cubed. And what we do for synthetic division, we always bring the first number down. Okay, so 1 goes below the line. Anytime you're below the line, you multiply by the number in your box. Okay, so 1 times 2 is 2. We add these together, we get 2. 2 times 2, since it's below the line, 2 times 2 is 4. Put it over here. 0 plus 4 is 4. We take 4 times 2, and we get 8. And we add these together and we get 0, and we're happy. Okay, I think you guys remember me drawing a million smiley faces, because it should kind of work out if we've done it properly. This 0 is our remainder, the 4 is our number, the 2 is our x, and the 1 is our x squared. So really, we can rewrite the whole top as not only this factor right here, but also x squared plus 2x plus 4. Let's go ahead and make our little fraction bar. We have x minus 2. And we also have x squared plus 2x plus 4. That's in the top. Alright, so let's go ahead and do the bottom then. Okay, this is just a simple x factor, so we take -8, 1 times -8, and in the bottom we put the middle number, 2. So what multiplies to -8 but adds to 2? 4 and 2 somehow, and the 2 needs to be negative, so 4 times -2 is -8, 4 plus -2 is +2. We divide that by 1, divide by 1, so we have our little factors from here, x plus 4 and x minus 2. We need to see what cancels out. We see x minus 2's cancel out, and we're left with that trinomial over this binomial. Okay. So let's go down here. On top, in the numerator, x squared plus 2x plus 4. In the bottom, we have the x plus 4. And we need to say we can't use these specific numbers. So first off, we cannot use -4. X can't be -4. And then we also have to look, even for the things that we crossed off, x can't be +2. Okay, that would make this whole thing 0. And you would die if you divided by 0. Don't do it. Okay. Alright, so that is our answer for number 10. Okay, that's all we got for today. So make sure that you're behaving for Mr. Williams. Alright, he will hand out a little bit of homework that you guys can work on in pairs if you would like. Okay, but it's going to be due next week when we come back. Alright, if you have questions, be more than happy to answer them on Thursday. Thanks, guys. Have a great day. See ya tomorrow.